So let's see about this problem. The position of a particle moving along a number line is given by the position function s of t equals sine of t, where t is greater than or equal to 0 is the elapsed time. So t is the time in seconds. In the first 2 pi seconds, which is roughly 6.28 or whatever, because it's 3.14 times 2. In the first 6-ish seconds of motion, when is the particle speeding up? So really, we're thinking about t. Well, we already know that it's got to be equal to 0 or bigger, and then the biggest that we're concerned with is 2 pi, which is roughly around 6 seconds. So, in the first 6-ish seconds, when is the particle speeding up? Remember, speeding up means that either the acceleration is positive and the velocity is positive, right? That means speeding up, or they're both negative, and that means speeding up, because a negative times a negative is a positive. You can remember it that way. So, what we need to do to solve this problem is first figure out the velocity function by taking the derivative of sine of t, then find out the acceleration function by taking the derivative of velocity, and then set those equal to 0 and make a sign chart for each, and then see where they overlap. So that's what I'm gonna do. Let's take the derivative of sine will be the velocity, and that's just cosine of t. The derivative of velocity is acceleration, and that's negative sine of t. And then, well, I'm going to do a sign chart for v of t. And that means I'll have to set v of t equal to 0. So cosine of t equals 0. Where does that happen? Well, on the unit circle, cosine is the x-coordinate, and cosine is 0 at pi over 2. And also at t equals, I guess that's 3 pi over 2. So there we go. There's our two t values that make cosine 0. So let's do a sign chart. If we have pi over 2 and 3 pi over 2, those are our critical values. Something smaller than pi over 2, since this is pi over 2, something smaller than pi over 2 is in the first quadrant. Something larger is in the second or third quadrant. And then something larger than 3 pi over 2 is in the fourth quadrant. So if you know those angles, that's how you can choose your test points. And that's what I'm going to do. So here are my test points, and here's my sign of velocity. And I'm just going to plug stuff in. It's really simple. We actually don't even really need test points if we're just looking at the unit circle, but we're going to pick stuff anyway. So let's do pi over 4. If we had pi over 4, that's definitely in the first quadrant. And if we plug that into our cosine function, what do we get? We get positive root 2 over 2. So we get a positive. Plug something that's in the middle here. That'll definitely give us a negative for cosine. Whoops. Let's just say pi, because that's definitely in the middle. That's definitely negative 1. And then let's try something over here. 3 pi over 2. What's like 11 pi over 6? Is that over there? I think that's over there. 11 pi over 6. It's not really necessary to know exactly the test point, just because we already know over here cosine is positive. So we have that. So there we go. There is our sign chart for velocity. Now I'm going to do a sign chart for acceleration. So that means I'll take my acceleration function and set it equal to 0, sine of t. And, well, here we're looking for all the t values that make sine 0, because whatever makes sine 0 is the same thing that's going to make negative sine 0. So what makes sine 0? Well, 0 does. T equals 0. Also, t equals pi. t equals pi, and we're going all the way to 2 pi, so I guess t equals 2 pi is another one that makes it 0. So I have 3 points here, and it says t can only be greater than or equal to 0, so we don't need any test points that are to the left side of that. So that's nice. So let's do this. Pi and 2 pi. And we'll make the sign chart here with test points, TP, and then sign of acceleration. And we're just plugging stuff into the acceleration function. So left of 0, nothing. We don't include that. In between 0 and pi. Well, what's in between 0 and pi? Pi over 2 is nice. Pi over 2. And in between pi and 2 pi, well, let's just do 3 pi over 2. Over 2. And we actually don't care about above 2 pi anyway either, because, we don't care about anything above 2 pi just because it says in the first 2 pi seconds of motion what's happening. When is the particle speeding up? We want speeding up. Okay, so if we plug in pi over 2 to this, well, sine of pi over 2 is positive 1, but then we have that negative, so we get negative. And then 3 pi over 2, sine of 3 pi over 2 is negative 1, times that negative, that's a positive. So there we go. Now, really, you can look at these two sign charts and you can see where they overlap. Remember, we're looking for either positive, positive, or negative, negative, because that's when the particle is speeding up. Or you could just draw a number line for both. So that's what I'll do. This one's for v of t. And I put on the critical values, so these ones, I put those on the number line for everything. So I'll just start out with 0, and then the next thing is pi over 2. And then what's next? Pi. I'm combining these, all the critical points. And then 3 pi over 2, and then 2 pi. Right? That's how it goes. And I'll do the same for acceleration. Alright, so here we go. I have them kind of lined up so that you can see where the things overlap. These are lined up. That's important, so it's easy to see. And then for velocity, okay, from 0 to pi over 2, we have positive velocity. So from 0 to pi over 2, that, I'll do it in green, that from 0 to pi over 2, we are positive on velocity. And then from pi over 2 to 3 pi over 2, pi over 2 to 3 pi over 2, that's from here to here, that's negative. And then from pi over, 3 pi over 2 onwards, we have positive. So that's all the way to 2 pi. It'll change again after that, but we're not concerned with after that. So that's for velocity. And then for acceleration, we just have from 0 to pi being negative. So from 0 to pi, we are negative. So that's negative. And then from pi to 2 pi, we are positive. From pi to 2 pi, we are positive. So let's see where they overlap. In this section, right here, we have negative and positive. That's not what we want. That means the particle's slowing down. From in this section, we have negative and negative, so there's an interval that is useful to us. Let's see. So from pi over 2 all the way until pi, we are slowing down. Sorry, no. Negative times a negative is a positive. We're speeding up. Okay, cool. From this interval, that's a negative here and a positive there, so that's not what I want. That's slowing down. And then I have positive and positive. So there, also, from 3 pi over 2 to 2 pi. So let's see if those are part of our answers. Pi over 2 to pi, is that there? Pi over 2 to pi. And 3 pi over 2 to 2 pi. 3 pi over 2 to 2 pi, both of those. that's where the particle is speeding up. There we go. Sweet.